Hello students. So today we are going to work out questions on the application of differentiation. So let's start with this question. Here y is equal to root sine root x. We have to find dy by dx. So obviously you know what you have to do. You have to apply chain rule. So what is y? Root of this. First you can write root of this. Okay, with respect to this you will do, right? Then this, what it is, first of all let's write this is sine root of x, right? Then here also it will be sine root of x, then sine root of x. Now this is next, when you are going to do this is sine of this, so differentiation it will become with respect to root x, and then again the last step you can do differentiation of root of x with respect to x. Okay, so now let us apply. First understand how did we write this. Okay, so the root of this we have written sine root of x, so root under this, okay, with respect to this we are taking. Why? Because root x differentiation with respect to x we know, so we can take this whole thing as x. Okay, then next we have to write the same thing which is in the denominator, so differentiation of sine of root x. Now in this we can write differentiation sine of this with respect to this, okay, and then finally root of this with respect to this. So in this way we can break it. Now we have to just write the formulas. Okay, so root of this is 1 by 2 root this, so this we have to now just write formulas. Sine differentiation is cos, so it becomes cos root x, and here root x is 1 by 2 root x. That's all. Then after that you just rearrange and write it. So cos root x divided by 4 root under x you can bring inside, so x sine root x. Okay, so that's the answer for this. Now let's move to the next. Sometimes the angles are given in degrees. Here you can see this x is in degrees, so we need to convert into radian before we differentiate. So you know that 180 degree is equal to pi radian, right? So 1 degree is pi by 180 radian, so x degrees will be pi x by 180 radian. Okay, now we can substitute it. So one step you can write before substitution, d by dx of sine x is converted into pi x by 180. The angle has been just written in terms of radian. Okay, now d sine of this with respect to this, and then this with respect to x. This is how we can break it. So what is this? This is pi x by 180, pi x by 180, pi x by 180. Okay, chain rule we are applying. Then further you can break it, right? The sine with sine of that with respect to x will become cos, right? Cos, and here pi by 180 will come out constant. X differentiation with x is 1, right? So that's what is the answer. This angle is pi x by 180. So that's the answer. This is what we have got, right? Okay, so let's move to the next. Now this comes under kinematics applications. Let us see that. So the position of particle is given by the equation. Okay, this position, this s is position. Sometimes in textbooks you will see that it's written as small x. Okay, x. I am just writing x instead of s. So function of time t cube minus 6t square plus 9t. Now time t is time and s is in meter. Okay, acceleration we have to find. What is the acceleration after 4 seconds? After 4 seconds means at 4 seconds you can take. So let's first find velocity. So velocity is defined as v is equal to dx by dt. This application you have to remember, velocity is defined as rate of change of position. Okay, so now we can do differentiation, calculate velocity first. So differentiate this t cube minus 6t square plus 9t right, with respect to t. So when you are going to differentiate t cube differentiation, 3t square minus 6t square differentiation is 2t plus 9 comes out, t differentiation with t is 1, right? So this is what it is, velocity. Then what is acceleration? Acceleration is rate of change of velocity. So acceleration definition is dv by dt. This is the definition of acceleration which you need to know. Okay, then let us do that. Calculate acceleration, dv by dt. So let's differentiate it. So 3 comes out, t square differentiation is 2t. Here this is 12 comes out, t differentiation it is 1. 9 is a constant, that differentiation is 0. So we get acceleration as 6t plus 12, right? That's what is the acceleration that we are getting, right? Now they are saying acceleration at 4 seconds, so we can substitute 4 here. So how much it will be? Let's calculate acceleration when time is 4. So 6 into 4 plus 12, right? So this will become 24 plus 12, that means 36 meter per second square. Okay, this is how we can calculate acceleration. If they ask velocity calculation at a particular time, then we can use this and we can substitute time here. So like that we can do calculations. Okay, next question. The area A of a circle is related to its diameter by. This is how area, we know already, right? Area of a circle is pi r square. Radius is half of diameter, so it will become d by 2. When you substitute d square by 4, it will become. So this is the area, right? Area of a circle. Okay. How fast the area changing with respect to diameter when diameter is 10 meter? So with respect to diameter, how it is? So we need to find out dA by and with respect to dd. Okay, this capital D is the diameter. With respect to diameter, you have to differentiate. So area, you write pi by 4 d square. With respect to capital D, you are doing differentiation. So pi by 4 is a constant, comes out. Now you have only d square with respect to d. That differentiation is 2 into d. Correct. So from here you get it as pi d by 2. Now you can substitute value of diameter 10 meters. So pi by 2 into 10. That means it is just 5 pi. Okay. So 5 pi is the rate of change of area with respect to diameter. Okay, like these questions we can find out. Then let's take this question. Experimental and theoretical investigation reveal that distance of a body, distance released from rest, falls in time t is proportional to the square of the amount of time it has fallen. We express this, so s is equal to half gt square. S is distance, g is acceleration due to Earth's gravity. This equation holds in vacuum where there is no air resistance, but it closely models the fall of dense heavy objects in air. Figure shows the free fall of heavy ball. So there is a free fall happening, but is falling, okay, from rest, released from rest, and it is in vacuum. So at time 0, okay, it is at rest. Okay, how many meters does the ball fall in first 2 seconds? First 2 seconds means time 0 to time 2 seconds. What is the distance? So as here refers to the distance, so we have to just substitute the values. Half g is basically 9.8, right, and t square, so 2 square. Okay, so from here it is like 4.9 into 4, correct? So you can calculate this, how much it will come. 6 and 16 plus 3, 19, right? So 19.6, isn't it, meter. Okay, that's the first part. Second part, what is its velocity, speed and acceleration then at that time? That means at 2 seconds only they are asking what is the velocity. So again here velocity is rate of change of displacement. S is the displacement because it is going downward in that direction, right? So ds by dt we can do, let's differentiate. So half g comes out because it's a constant. T square differentiation with t is 2t. So that becomes gt, isn't it? So now at 2 seconds you can just substitute the values. So what will be the value? G is 9.8 into 2. So that will also be 19.6, isn't it? But this is meter per second. This is the speed. Velocity. So velocity and speed is same only, isn't it? At that point, what its velocity, speed, and acceleration. Acceleration also we have to calculate. So acceleration means it is just dv by dt we have to do. So if you are calculating acceleration is dv by dt, but velocity has to be function of time, so that means we have to use this one, right? Gt. So g comes out, t with t differentiation become 1. So that's what is g, which is 9.8 meter per second square. That's a constant acceleration. So we can understand that acceleration is a constant value. That's a free form, right? So these are certain applications in kinematics. More detailed application you will be seeing in those chapters. Okay. Now some application of maximum minima that we should know. Find the minimum value of y. So like this, we have to find maximum minimum. So first thing you have to do is dy by dx. So differentiate it. Differentiation of 1 is 0, 1 is constant, x square differentiation is 2x, minus 2 comes out, x differentiation with x is 1. Okay, this is what it is. So dy by dx you got, right? That is 2x minus 2. If you want, you can do double differentiation, d squared by dx square. That 2 will come, x differentiation is 1, right? And 2 is differentiation 0. Now double differentiation positive. I hope you understand what is double differentiation positive. The shape of the graph will be like this. So you see here they are asking the minimum value only. That means this is the point. So that is the minimum here, right? So now minimum condition is dy by dx has to be equal to 0 at either maximum minima, that dy by dx is equal to 0. Remember. So just equate dy by dx is equal to 0. So that means 2x minus 2 is equal to 0. That means x is equal to 1. So at 1 there is minima. Now we substitute x in the function. So what is value of y when x is 1? Substitute 1 plus 1 square minus 2 into 1. So that becomes 0. So 0 is the minimum value. This is the minimum value of y. Okay, here they are not asking the maximum value because there is a minima happening here. Why? Because double differentiation is positive only. If it is negative, then only shape of the graph will be like convex. Then in that case they can ask maximum, right? Okay, so let's take the next question. Particle position is a function of time is given. Find out the maximum value, the position coordinate. Also plot the graph. Also we have to plot the graph. Okay, so again we will do dx by dt, differentiate. So 5t square is 2t, so this will become 10t minus 9, right? And double differentiation will give us the shape of the graph. You can see this is just 10. It is positive, right? So the shape of the graph has to be concave. So it should be the minima, right? Here it is minima, not maximum. So I think this is not correct in the question. We have to find the minimum value. Minimum value. Okay. Anyway, now let us try to find out where is minima happening and what is the minimum value. So the x by dt we have to do 0, right? So when you do it 0, 10t minus 9 is 0. That means time is 0.9 second. Okay. And what is the minimum value? The minimum value of x, we can substitute this time. So 5 into 0.9 whole square minus 9t plus 3, right? T means here 0.9, isn't it? 9 into 0.9 plus 3. So calculate this, how much it will come, isn't it? So how much will be the value? Just calculate. I think this will be minus 1.05. Okay, this is the position. Now you see, if you have to plot the graph, okay, let's try to plot the graph. Suppose this is time and this is xt graph we are plotting, right? It's a parabola and the minimum value is happening at 0.9 second. So if you take this as 0.9 second, here minimum value is happening, isn't it? And you can also find out whether it is cutting the time axis or not. Whenever it will be cutting the time axis, so there will be two values of time. Obviously it will be two values of time, isn't it? You can find out those two values of time. You can put x is equal to 0 and find out those two values of time, right? So what it will be? So it will be 5t square minus 9t plus 3 is equal to 0. So there will be quadratic equation. You can calculate minus b plus minus, right? Plus minus b plus minus root under b square minus 4ac. So 81 b square minus 4ac. So how much? 20 into 360, right? 4ac by 2a, that means 10. So how much it comes? You can check the values. So 81 9 plus minus this becomes root under 21, okay, divided by 10, isn't it? So this value we have to find out. So time cannot be negative, so check whether it can come negative. No negative, both the values will be positive, isn't it? So there will be two values of time, positive, one will be like this side and this side. So the graph which will be actually looking is, it may go like this, right? It may go like this. It's a parabola, it's a parabola graph, and there will be minimum value happens, and the minimum value is negative. So that's why you can see here this graph, this will be the minimum value happening, okay, at 0.9 second minimum value. It will be cutting the graph at 2 points. For those 2 points there will be zero displacement, okay, fine. Then let's go to the next question. A hot air balloon rising straight up from a level field is tracked by a range finder 500 feet from the liftoff point. Okay, at the moment the range finder's elevation is pi by 4. The angle is increasing at the rate of, okay, how fast is the balloon rising at the moment? Okay, so we need to draw the diagram first of all. So consider that this is the height of the balloon at a particular point. A hot balloon rising straight up, it is going a level field by a range finder 500 feet from the, so this is like 500 feet, let's say, so 500 feet, okay, and it is being measured like this. So some angle theta is there, right? At the moment the range find elevation is pi by 4, so theta will be changing as balloon will go up. Let us say here this angle will change, right? So let's say this is a small change in angle d theta, and this is the height, let us say, and this will be small change in height dh, right? This distance is not changing. I think this distance will be fixed, okay. How fast the balloon rising? So we have to find out dh by dt, right? This is what it is. How fast means how the height is changing with respect to time, okay. So how do we calculate, and what else they have given? They have given d theta by dt. The rate at which it is changing is 0.14, okay, and at a value of theta pi by 4 we need to calculate this, okay. Angle is increasing at this rate, okay. So how do we calculate it? This distance is constant, so what we can do is we can apply trigonometry, isn't it? We can apply trigonometry. Suppose if you take tan theta. If you take tan theta is h by d. D is a constant here, so h is equal to d tan theta, right? Now you find out dh by dt. Dh by dt, when you do, your d is constant, it comes out, and differentiation of tan theta with time. But time, instead of doing time, you can apply chain rule, d tan theta with d theta, then d theta with dt. This we can do. So this distance d is, we can calculate that. Let it be, differentiation of tan theta is secant square theta, right? And d theta by dt, they have given 0.14. Now what is the value of theta? They have given 45 degree, and if this is 45 degree, then obviously this length and this length will be same, isn't it? Because this is 90 degree, and if this is 45 degree, so this is also 45 degree, so this will also become 500 feet. Okay, 500 feet at that 45 degree angle. So then we can substitute here this value. Okay, this is 500 feet, right? Feet, and all other things are constant. That means their units are in per second we can take. So secant square 45 degrees, so it is like cos is 1 by root 2, so this is root 2 square is 2, and this is 0.14. so this dh by dt, finally it can calculate in terms of feet per second, because they have given feet, right? So here 100 factor will get cancelled, and you will remove that, and 5 into 10 extra 10 will be coming, so this will become 140 feet per second, right? That will be the answer. So in this manner, these are some of the applications which you can see, that will be coming in physics. Then next, one more application, let's see. A police cruiser approaching a right angled intersection from the north. So a police, let's say this is P means this is police, right? It is following, it is coming a corner. Okay, it is coming from north, so it is coming like downward. Okay, downward means from north towards south it is coming, right? A police cruiser approaching a right angle intersection from the north is chasing a speeding car that has turned round the corner and is now. So another, there is a car which police is chasing. This car you can take as C. Okay, this is going towards east. Okay, and this is 90 degree. When the cruiser is 0.6 mile north of the intersection, the car is, so they have given these distances. This distance they have given, right? And this is also given. So this is 0.8 miles. ml means mile, and 0.6 mile. Mile, what is mile? 1 mile is approximately 1.6 kilometer or 1600 meters approximately. We can convert it if you need it. Otherwise you can keep answering miles yourself, because they have not asked, right, in which unit we have to be. Okay, so let us say then what is the question, that when the cruiser is at this distance, right, the car is this, the police determine with radar that the distance between them and the car is increasing. That means this distance we is talking about, right? This distance is increasing at a particular rate. Okay, so let's say this distance is r. This distance r is increasing, dr by dt is 20 miles per hour. Okay, this is miles, I think, 20 miles per hour. If the cruiser is moving at 60 mile per hour, cruiser, that means the police, this is going with 60 miles per hour. Okay, and at this instant what should be the speed of this? Okay, so you can take this, let's say this is x and this is y. We have to calculate dx by dt. Okay, and this y is decreasing, so basically dy by dt is negative. We know that it will be negative. And how much? That is speed is 60, so minus 60 you can take. Okay. So now let us do the calculation. So you can apply Pythagoras theorem if you want. That's the best. R square is equal to x square plus y square. Okay. So now differentiate with time and apply chain rule. So r square with r you apply, right? If you want one step, you write differentiation of r square with t, differentiation of x square with t, differentiation of y square with t. But then next step you apply chain rule. Okay. So r square with r will give 2r and dr by dt. Okay, this will become dr by dt. Then x square with x is 2x dx by dt. That is what we have to calculate v, right? Plus similarly 2y dy by dt, that is given as minus 60. Okay, so now substitute and calculate the values. We need to just find out, right? So at this position, when this is x is 0.8, y is 0.6, how much will be this? You can do root under, right? It's a Pythagoras theorem. So at this point, what it will be? Because 0.6 square is 0.36, 0.8 square is 0.64. So I think this will come 1, right? 1. So r is 1 at that instant. 2 factor will anyway get cancelled. 2 you can cancel out. So r is 1. dy by dr by dt, this is 20. Let's keep miles per hour only. We don't have to convert units. X is here 0.8. V plus y is 0.6. 0.6 into minus 60. Okay. So from here, after you calculate, what will be v? V you can calculate from here. How much it will be? Because this minus will go that side, it will increase, right? And this 10 factor will get cancelled, and this will be 36, right? So 20 plus 36, 56, 56 by 0.8, right? It will become 70. So it will become 70 miles per hour. Okay, so that will be the answer for this. This is a typical application in kinematics. You will be seeing that. Okay, next. Water pours out at the rate of Q from a tap into a cylindrical vessel of radius r. Cylindrical vessel, okay. The rate at which the height of water level rises when the height is. So suppose there is a cylindrical vessel. Okay, and the water is pouring into it from some tap. Okay, so it is getting filled, and let's say it has got filled to some height h. So we have to calculate dh by dt. dh by dt, rate at which level is changing. Okay, and the rate at which it is falling, water pours at the rate of Q from a tap. So there will be a tap. From that tap, it is falling at a uniform rate. What is Q means here? What is rate? Because when you are counting the rate, how will you count this rate? Q. Q is, I think, it is the volume per second. Okay, Q is nothing but it is volume per second. How much volume per second per unit time water is falling down. So now this is volume flow rate. So the volume which it will be, let's say, going to fill, first calculate the volume. Let's say the area is A. I think they have given the radius here, right? So what is the volume here? The volume will be pi r square area into h cylinder. Now the rate at which volume is changing, they have given this dv, d volume with respect to t. Okay, so of course when you differentiate it, this pi r square doesn't change, it's constant. Then dh by dt, this they have given as q, isn't it? So from here dh by dt becomes q by pi r square, isn't it? So from here we can understand that the state at which height is changing is q by pi r square. So correct option will be option B, right? So I hope you have understood questions how to attempt on differentiation. Then next class we can start integration and then we will continue further. Thank you for your attention.